All right, hello, geometry. Here we go. Chapter Unit 9, Transformations. We're doing 9.1 today, which is translations. So this is our first type of transformation. Transformation just means to change. So we're going to take a shape and change it. And the first way we do this is a translation. All right, so in general transformations, if we transform a shape, it can result in a change in the position. And this is what we focus on in Unit 9. Okay, so we're going to, we're going to translate it. Which is to slide it. And we're going to also, we can flip it, which is your reflection. Or we can rotate it, which means to turn. Okay, rotation. The word's there. Also, I just wrote it below so you can see it both places. All right. So the other blank here is, all of these are the position is translate or reflect or rotate. The other thing that can happen is you can change the shape and the size. All right, and that would be a dilation. Okay, so the shape and the size is a dilation. We're actually not going to cover the dilations this year due to the lack of time that we have. And that's really already kind of covered in similar figures, sort of, at least with the size. The shape would just be we covered under a dilation, but we just had to skip something, so this time we're not going to do a dilation. Anyway, we're just going to stick to the translate, reflect, and rotate. So the slide, the flip, and the rotation. Okay, so the first one we talk about today is the slide or the translation. All right, but here's 3 examples of them. Here's a translation, the domino slides. Okay, it went down, basically, and over. It slid down, and it slid over. Actually, we would go in the order of X and Y, and we would slide over and slide down. To describe it, we have to go left and right and up and down. We can't go diagonally. This is a reflection. That's just going to flip. So it's going to have a line of symmetry and flip. That comes in 9.2. And rotate comes in later on as well, 9.3, when it takes a turn. Turn, flip, slide. All right. So the original figure is called the pre-image. And the resulting image after the translation is called the image. So what you're given is actually the pre, and what you arrive at is called the image. So that's kind of weird to think about. So you're going to start not with the image. You're going to start with the pre-image, and then once it gets transformed, it becomes the image. Okay, so a couple of just vocabulary words here. Rigid motion or an isometry. These are all mean the same thing. A rigid motion is a transformation that preserves distance and angle measure. Angle measure meaning that the size and shape stay the same. Okay, so therefore the pre-image and the image are congruent. Okay, so all of these are going to be rigid motions. This stayed the same, this stayed the same, this stayed the same. The size and the shape stayed the same with all of these, only the position changed. So all of these are rigid motions, and all of these are isometries. The only one that's different is the dilation, and we're not covering it. So, easy. Okay, so tell if this is a rigid motion. Okay, so here's the pre-image and here's the image. And you just want to see if they look to be congruent. And this would be yes. This would be no. This got smaller. And this would be no as this got smaller. So it's a pretty easy concept. It's just vocabulary words with rigid motion and isometry. Okay? So notation is really the trickiest part of this chapter. We're going to get really mathy here with our notation. A transformation maps every point of a figure onto its image. And it's going to be described with arrow notation. And then prime notation is most often used to identify the image point, so the resulting figure. All right, so this just says that you have J, K, Q. Okay, so here's J, K, Q, triangle J, K, Q. This is the start, okay? And what has happened with J, K, Q is it has just slid along an equidistant, path here and landed here. So this JKQ is the pre-image, and it has incurred a transformation, and the resulting image, or the image, is J prime, K prime, Q prime. Okay, so this notation up here means prime. We can say it maps. This arrow means it maps onto. So it's just moving a little distance, and it's just going to map onto that. Okay. Practice. The smaller triangle is an image of the larger triangle. So this is the image. So that's the result. It got smaller. Here's the pre-image. The pre-image maps onto the image, and you can see the little prime. So if you can't see down there, you can see the little prime notation down here. All right, so the image of angle M is M prime. The pre-image of angle P prime, which is the resulting image, the pre-image of that would be just basic angle P. MP corresponds with M prime, P prime. Beginning image, resulting image, pre-image, resulting image, or just image. And the image of triangle MPN is just M prime, P prime, N prime. So this is just mathy, nerdy notation stuff. Okay, so maybe you guys didn't get a chance to see that. Pretty straightforward. All right, next page here. All right, so let's talk about this first one, this translation, and talk about how we're actually going to write all of this. All right, a translation is a slide that maps all points of a figure the same distance in the same direction. Okay, so let's look here. We basically have AB. I'm going to start right here. AB is congruent to A prime, B prime. So that's a side. BC is congruent to B prime, C prime. And AC is congruent to A prime, C prime. All right, so those triangles are congruent by SSS, right? Those are congruent by SSS. Okay, and we're just gonna, and so if they're congruent by SSS, you also have the angle A equals A prime, B equals B prime, and C equals C prime. All right, so we've got these congruent figures. So what you want to do to get a translation is a rigid motion. You're going to take this triangle here, and it's going to slide the same distance. So this distance A to A prime, let's say it slid 5 units. Well, then point B needs to slide 5 units, and point C needs to slide 5 units. All of those need to be the same. So A needs to map to A prime, B to B prime, and C to C prime for it to be a rigid motion. So basically this congruent triangle slides, and where it lands, you know, if you were to record the pre-image and record the resulting image, or just the image, you would see that those are congruent triangles. I mean, it's the same thing. It just incurred a slide. All right? And so you're looking for the shapes to be congruent because they're going to be a rigid motion or isometry, and you just want to look for the same amount of slide. All right, so our notation. So here is the pre-image because it doesn't have the prime, and here's the resulting image, or just the image itself. In the translation shown in the diagram, each point is translated 2 units. So let's just pick a point and check. M goes 2 to the left. P goes 2 to the left. N goes 2 to the left. All right, and so if M goes 2 to the left, to map onto M prime, it went 2 to the left, and then it also went 1, 2, 3, 4 up. P went 2 to the left, and 1, 2, 3, 4 up. N went 2 to the left, and 1, 2, 3, 4 up. So that's a congruent slide. That's a congruent slide to the left and slide up. So in this translation shown in the diagram, each point is translated 2 units left and 4 units up. So each point XY of M and P is mapped to X minus 2, that's left 2, and Y incurred a plus 4. So, whatever this point is, it went left 2 up 4. Whatever this point is, the XY went left 2 up 4. Whatever this point is, it went left 2 up 4. So how do we write that? So you're going to write T for translation. All right, T for translation. Okay, and then this is your XY. When you write this, you draw these little arrows here, kind of instead of parentheses. And this means, this is your left-right movement. That means left 2. And this means up 4. And then in parentheses, behind it, you put the pre-image. And what does that equal? The resulting image, or just the image. So here it is laid out. Uppercase T means translation. You have this kind of weird parentheses, these little, they look like less than sign and a greater than sign, but they're here. That's just XY. So this will tell you your left or right movement. This will tell you your up and down. Name the pre-image. Sometimes it's just points, XY. Sometimes the problem will give you a triangle or a square or a rectangle or what have you. Sometimes it'll just give you a point XY, and you just have to, shift just the coordinates. And then this is the resulting image, or just the image. All right. So here we go. So you just really need to know what to read here. Graph the image of T, which incurs a translation of 3 right, down 1, and here is the pre-image, ABC. So we're just going to take each point and go right 3 and down 1. Okay, so here we go. 1, 2, 3, 1. That's A prime. 1, 2, 3, 1. That's B prime. And 1, 2, 3, 1. That's C prime. Easy, easy. That's it. So what you're learning to do here is just follow weird math directions. All right. Write a rule to describe the translation of the solid figure to the dashed figure. So the solid figure is going to be the pre-image. And we're going to the dash, so this will be the image. Okay, and so I don't have a name of this triangle, so I'm going to say that this incurred a translation. Okay, this incurred a translation, and we're going to the solid figure to the dash, so it went left 2 and up 2. So check each point, left 2, up 2, left 2, up 2. check each vertice, left 2, up 2. So they all checked out. They all went left 2, up 2. If the triangle had letters here, I would name this triangle, you know, X, Y, Z, A, B, C, L, M, N, whatever. And then over here I'd say triangle X prime, Y prime, Z prime, so forth and so forth. But there's not named. So for this one I can just say X, Y, and it ended up equaling X prime, Y prime. The ordinates, the coordinates, all just incurred that negative 2 to 2. All right, find a translation that has the same effect as this composition of translations. So this is 2 translations because it says that we're doing a right 5, up 4 of XY, and then it has another one. It gets a left 2, up 3. All right, so find a translation that has the same effect as this. So I've got a blank space here. So let's just put a random point. Pick a random point. XY. Okay, it doesn't say that I have a triangle. It doesn't say anything, so we can just do a random point. I'm just going to put a point right here. I don't know, right there. P. Okay, so if I go 5, 4, if I go right 5, up 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, I land here. Okay, so this is a mid step right here. 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's my first pre-prime. And then it's followed by left 2, so back it up, left 2, up 3. Okay, so now we'll go left 2 and up 3. Left 2, up 3. And so this is the true resulting figure. This is kind of the mid step. Okay, so what would have been an easier way to write this? 1, 2, 3, right 3, 1, 2, 3, 4, 5, 6, 7. So an easier way to write this would have been just to go right 3 and up 7. So an easier translate right 3, up 7 of random point XY, and it will equal X prime, Y prime. All right. So I know this notation is new, but it's pretty easy. Just follow the directions and you'll be all right. Okay, so we will see you next time. Thanks. Bye.